Totally private and secure messaging from anywhere to your own AI running on your own hardware is totally possible. And privacy and security is only going to matter more as we start to see more implementations of AI agents that undertake actions on your behalf autonomously. Today we're going to be using Mistral 7B, an extremely light and performant reliable local large language model, or LLM, hosted on your own local consumer hardware to create an interactive AI available to chat to from anywhere through the Signal messaging app, private and secure by design. This is the first in a series of videos where we'll be building towards a self-hosted autonomous agent system, but we're starting with a basic AI assistant today. We'll demonstrate getting Mistral up and running locally using Ollama. We'll set up an interface to Signal via signal-cli. We'll combine them to expose your Mistral instance over Signal for ongoing conversations. And finally, we'll implement it to run in the background so your private, secure AI assistant is available whenever your computer is up and running. I had reservations about how my computer would perform with these services running constantly in the background, so hang around to the end to see how a mid-range desktop like mine handled it. We'll run through 4 steps in this fairly short video. And you can easily get this up and running in an hour or so, since you can avoid all the pitfalls I had to navigate, and you'll get some extra resources that I'll drop in at the end. I'm developing on probably the hardest platform for all of this, Windows, so things will probably be much easier for you if you are using Linux or Mac. And I'll walk you through the development environment before we get started too. Let's go. I'm developing in VS Code. I also have extensions for Python installed, since I'll be coding in that language, and for WSL, that's Windows Subsystem for Linux. Ollama doesn't have a version that runs native to Windows, so we'll be needing to use WSL. If you don't already have Windows Subsystem for Linux installed, you can go here to install it. It is as simple as a single command, though. I chose the Ubuntu distribution because I know that the NVIDIA drivers, we're going to want GPU acceleration, support it. You'll want the CUDA toolkit. There's a distribution here specifically for WSL Ubuntu, and that's what you're looking for. Also, when I first tried this, Ollama couldn't find the tool NVIDIA SMI, which it needs to verify that it has the tools available to use GPU acceleration. So I had an extra step. I created a shortcut in the WSL shell in VS Code. I ran this line. I made a shortcut to the mounted location of where that toolkit is, so it would exist where Ollama was expecting to find it by default on a Linux system. That may not be necessary anymore, but if when you run it, it can't find NVIDIA SMI, then maybe try that. That might fix it. And I have made a virtual environment for the development here. I've used the one inbuilt into the Python tools in VS Code, but you can look up how to do it. If you use Anaconda, that's fine as well. You can do the whole Conda create. I like the built-in virtual environment of Python. They use that instead. Control-Shift-P to bring up this command palette. Python, it'll come up there as create environment. You can give the options to do that. Then when you've done that, you should verify that it's actually using it. The terminals tell you here if it's using the current virtual environment. So this one isn't. Here's the command to do that. Type source, and it's in the current directory .venv, because that's what I've named it here. Scripts, activate. And now you can see it's got this little venv, and then you can tell I'm now in the virtual environment properly. In case it's confusing, yes, this is Bash. I installed Git for Windows a long time ago, and I've been using Git Bash natively on Windows ever since. This isn't the WSL version of Bash working in the Windows subsystem. You can see the difference over here. One says Bash, that's locally in Windows, just Git Bash. And this is WSL, which will be Bash running in Windows Subsystem for Linux. Now we've paved the way to start getting Ollama up and running and serving Mistral for us. Let's move on to installing it. Mistral is a light, performant large language model. It runs well on consumer level hardware, and it's developed by a major AI company, Mistral. I don't endorse using a model where you don't know and trust the original developers, and that includes fine tunes, as there have been a number of demonstrations of attacks via sleepers. and I'd be surprised if that didn't make its way into the wild in the future. I don't think it's there yet. As autonomous agents based on LLMs become more prevalent, I think the risk of that is going to be greater and greater. Here we're going to use Mistral 7B Open Orca as the particular fine-tune. It's developed by Alignment Lab AI, a known group, and it's available through Ollama directly. So we're going to go on over to ollama.ai and download Ollama. We can't choose Windows because it's not available. We're going to choose Linux, and you can see here it's just a command you can run in your terminal. Granted, you should probably go and look at that file before piping it straight in and running it, but I trust it. I've used it before. I'm going to use that command. So we just paste that into our terminal here. That's our WSL terminal, and then we'll run it. Now I'm going to skip this part because, of course, I've already installed Ollama before, and it's easy to start up. You just type Ollama serve. Ready to serve our models to us. Well, if we have any downloaded. So that's the next step. Here in a second WSL terminal, I'm going to run one of the models. If I didn't have it, it would download it. I already do have it. Ollama run Mistral Open Orca. You'll probably start to hear your fans whirring at this point, and you can see in the background here it's running, outputting content and ready to serve the model for us. So let's type a message. In all honesty, it's refused to respond to any of my keystrokes in this terminal. I don't know why, it's never done that before, but that's not the only way you can send messages to Ollama. It is serving a server in the background that you can send HTTP requests for. This is how we do it, and let's see the response. As you can see, it's fairly quick. I don't know why it doesn't like to respond in the terminal anymore, but no problem, since we're going to be using this method anyway. And we've got a Python script to do exactly that, and this is the URL that Ollama is serving our API at. And we've got a couple of functions here. We've got some constants that actually we're going to be using later. We've got a default prompt of "you are a helpful assistant." You could change that in your own code. We've got some simple functions to print the current status, to print the conversation turns, and to print the conversation streaming. You see, we got a streaming response when we first tested, but let's say if we're going to write a message to send over Signal, we don't want lots of part messages. We want to collect the entire message and then send it. And we've got the simple function here to get the completion. Default prompt as hello, and it's going to simply send that as a post request to the API URL that we defined above. Then it's going to use these statuses as we've defined them throughout, just so we can see how far we're going. We're building towards something useful when we use Signal later. It's really useful to know whether the system has received and is working on a response. And there's a typing indicator in Signal, so we want to leverage that. Hence, we're starting to track helpful status messages sooner in our code. But if we simply run this script, then we're going to generate a couple of simple chat completions, and we'll see what we get. Here we go. And I can hear my fans start to whir up again. And it took about 30 seconds to get this entire message compiled and ready to send in one chunk. When we're using Signal, we won't want to see every couple of words come in as a stream. So that's roughly how long we should expect it to take between messages. That's fine for an asynchronous messaging application. And it's reassuring to know that Mistral, after telling us about Mary's lamb, suggests we shouldn't eat the lamb. Outsourcing the handling of basic asynchronous messaging functionality to a platform that is already expert in it and working flawlessly on multiple devices concurrently is a huge implementation simplification. Intermittent network connectivity and tight messaging app integration on Android, iOS, and even desktop operating systems comes for free and will be maintained for us as those platforms continue to evolve. By doing it this way, we get to leverage all that stuff without coding, maintaining, or evolving with new system capabilities ourselves. So it's a smart first step in implementing locally hosted AI tools that you can securely reach from anywhere. And while it might not seem at first glance that there's much advantage over using the ChatGPT app on your mobile for this initial proof of concept. As soon as we pivot from a simple chatbot to any autonomous AI agent with authority to act on your behalf with external services and with access to all your stuff, you can instantly see why private and secure by design will become a much more important consideration. Let's solve it from the start. Signal is the leading free messaging app that is both secure and private by design, with messages encrypted end to end. It's the recommended messaging platform by security experts everywhere, and it's run by a non-profit. Consider donating, or maybe buy some merch. And it's the only end-to-end encrypted messaging platform I've found where you can both send and receive end-to-end encrypted messages programmatically by a third-party open source program. And I've been looking for ages. End-to-end encryption is a must in my mind, as otherwise the platform owners could technically snoop on your conversation if they wanted to, or if they were required to for law enforcement reasons, for example. Most alternatives I've found where there is code to send and receive messages programmatically don't offer that. Discord, for example, doesn't offer end-to-end encryption. Telegram offers end-to-end encryption via so-called secret chats, but it's not default and it's not available to bots that you build using the available Telegram API. WhatsApp is end-to-end encrypted for message content, although metadata, which includes information such as who you message, when and how often, is not. That may be good enough for your purposes, and there do seem to be numerous open source packages available claiming to send and receive WhatsApp messages. However, they either rely on using the WhatsApp Business API, which comes at a cost per message, or are a hacked together way of programmatically using or pretending to be the WhatsApp web interface. That's too brittle for my liking, and it's definitely against the WhatsApp terms of service. So Signal it is, and we'll be using the open source Java program signal-cli to send and receive messages programmatically. With signal-cli on your computer, you can send Signal messages to your phone not only from any app that can run terminal commands like Python and shell scripts, but also you can use the so-called JSON RPC daemon to send an HTTP packet to the local machine to do the same. And that's what we'll be using here. So here's how to do it. We're going to first make sure we've got Java installed on the system. If you run from a command line, we're not using WSL anymore. Java -- version to see if you already have a compatible version installed. I can see I've got one there. It's version 21. Future releases will require version 21. I spotted on their website, and the current release works fine with that. So that's what I've installed here. The Microsoft build and MSI installer is probably the easiest method of installation. You can download that from here and verify it with Java -- version, just in case you have an old version to remove from your path. If you type which Java, if you're in Bash, or if you're in a command line aware Java, and you'll see which Java locations are available in the path. The top one is the one that's going to be used. To download the latest Signal-cli release, go to their GitHub page and find the latest release. You'll want the generic tar.gz version. You'll need something like WinRAR to unzip that on Windows. I've installed mine so that I have a signal-cli subfolder in my project folder, and there I've got the bin and the lib folders, and that's where it's expecting to find the executable. Use any mobile number you have access to that doesn't already have Signal up and running. The way that we're doing this is such that our bot will converse with you via your own Signal messenger set up on your primary mobile number, so your bot will need its own number to send from. I already have and use Signal on my personal mobile, and I have a secondary mobile for business that I've used here. You could use something like Twilio to get a new mobile number for cheap. Just make sure that you've set it up so you receive SMS messages somewhere, as a verification code will come through that way. You won't need to use SMS after number verification. You can even register Signal using a landline number. There's just a different process to follow. In a regular command prompt, simply type signal-cli-a, then the account number you want to use, register. I have seen that used differently in the quick start file. It's -u rather than -a. I can't remember which I used, but certainly one of them worked for me. If it works, there's no response. I got the request saying I needed a capture token, so I had to go here to this website, verify I am human. I opted not to open this application, and instead I copied the link here with a right click and copy the link address. Then I went back into the terminal and I used this command here with my telephone number and with the copied URL. Again, if you get no response, it's worked. You then get a verification code sent by SMS, or if you use the voice option because you're using a landline, you'll receive a phone call with it, and you'll want to put that back into the terminal with this command here. Again, no response means that it worked, and you should be able to test it by running this command here. Send from your telephone number to yourself or some other Signal account that you already have. Assuming that worked, let's start the JSON RPC daemon. You'll need to enter your number here. I've chosen port 11535 for this example. Now I'm going to run this in the background with my real number, but I won't be showing that to you here. You can test it with this command. This helpful check URL should return a status of 200. And there we go. So the daemon is up and running. And with this command, you can send a message to this number with this message. The ID just is a random number. Give that a go with your details, sending to your other number, and make sure you get the message. To test and make sure you can receive messages, let's kill that daemon and rerun it, this time with an extra parameter added. We use this so our code won't miss messages, as the daemon will now only get them from Signal when our client code sends a request to manually actively check for them. This makes sure we don't receive messages in the background when we don't have anything set up to do anything with them. Again, I'm going to replace that bot number with my real number and set that running in the background. Now, if you send a message to your bot through Signal, you should be able to run this code to receive it. The details that came back included all my telephone numbers, so I didn't want to show them on the screen, but I did receive the message that I intended to receive. It's worth noting here that the empty params object isn't documented in signal-cli anywhere, but it does seem to need it. So here's a Python script to do this programmatically. We've got a .env saving our telephone numbers to send from and to send to. We've got the URLs for locally doing this with the port number defined here. A couple of functions that we've written. One that's going to raise an exception if it's down. It's going to use that check URL and it's going to make sure it gets that 200 status code. If it doesn't, then it's going to raise an exception. We've got a simple function for sending a Signal message. It's going to follow that process that we saw earlier. We have a function for receiving messages, which will return an object including both the message and the timestamps of the messages that went into it. This means that if we had 2, 3, or 4 messages received at once, they'll all be concatenated together, but the timestamps for each will be shown. We want those timestamps because that's how we send read receipts. We want to know that our code has received those messages. And this is the code that we use to do that. We also want to send a typing indicator. Again, this is going to be more useful when we have a large language model doing busy work in the background and taking some time. We've got a function here to allow us to do that. And it's got a single Boolean argument. And it's going to use this code to send it. We have some convenience functions, a way of starting and stopping that simply calls that, and a really silly but easy function to test and make sure it's working. It's going to echo what it's received back to you and encourage that you continue. So when you get a message, it will say, "It's funny you should say," whatever it was you said, "I was just thinking that. Go on." Unless, of course, you've said, goodbye, in which case it will finish the conversation. And we have the code written for how it will poll for incoming messages. Remember, we did actively have to send a request to the signal-cli JSON RPC daemon to receive messages, so we have to do this regularly. It won't be automatically pushed to the Python program. And our main function will call that after waiting 5 seconds between each go. But once we say goodbye, and it notices the conversation's finished, it'll exit the program completely. So with signal-cli running in the background, we can run this program and make sure it's working. Now in the background, I'm going to send it a message. Now we have Python code to operate a chat with Mistral via Ollama and Python code to send and receive messages over Signal. Let's combine them. Now, since we'd already been coding with the end in mind somewhat, we import a lot of the functions that we've already defined. All we do here is define a function to handle incoming messages and a main loop that will first check that the signal daemon is running and then constantly poll and handle. In fact, there's no way that this one will actually quit, so you just have to quit it manually when you're done. Let's walk through the handle incoming messages function. It's pretty straightforward. Every time it receives a message, it's going to trigger the read receipt. That's great. You'll know that the bot has received the message. It's going to start the typing indicator, which is great because it's going to now hand off to the AI, and that could take a while to compile an answer to the question. Now, there's a very simple thread management in the background going on here. It's going to keep the message history until we say either goodbye or thanks. That means that you can have an ongoing conversation with Mistral for a good number of turns, but there's no managing the context window. So if we run out of context, you can expect a problem here. Also, as the conversation state simply sits in memory, there's no protection against resetting the thread when the computer restarts, which wouldn't be clear at first remotely from the message thread alone. But there's little benefit in solving these problems here, reinventing the wheel or finding a library to do it for us, when we know we'll soon be moving from this very simple chatbot interface, Mistral over Ollama, to some kind of agent system using a platform or framework that will already have loads of inbuilt ways to retain memory and handle growing contexts. But as a first step towards that and a proof of concept that we can do it, this is great. So let's see it in action. With Ollama and signal-cli now running in the background, let's run Signal Mistral. Alright, so this seems like a good use case for a private and secure conversation. I'm going to ask Mistral to suggest a good password for my internet banking, complete with an easy way to remember it. Let's see how it goes. So that's sent. And we've got the read receipt. And you see the extra ticks come up. And the typing indicator, so we know now that Mistral is busy composing a good password for us. It did take a good minute for that response to come back to us, but that's fine. This is asynchronous messaging and we weren't expecting an instant response. So what did it suggest? A memorable phrase such as "I love to travel, visit museums and gardens." The first initial of each word creates the password. IL2TVMAG. This makes it easy to remember while keeping it secure. Pretty good. Now, I don't want to be in a situation where I'm out and about and I want to send my AI a message, but I've forgotten to run all of these commands on my PC, especially when it's an autonomous agent system like down the road. If you're on Linux or Mac and can use systemd, for example, or whatever your default system uses to get things up and running as services start up, you should easily be able to start up Ollama and signal-cli and then wait a bit before getting the Python code running to connect them. After some serious trial and error on Windows, here's how we can get that running. And if you're worried about slowing down your computer, we'll touch on that a bit too. So I put together this batch file. I used quite a lot of AI help to figure out what the right commands were because I don't know all this stuff off by heart, but it's fairly simple to run through. First, we wait for 60 seconds. because the computer is going to take some time to do all its other startup stuff, and typically when I try and do things too early in startup scripts, they don't work. So we wait a little while and then start Ollama under WSL2 in the background. There's a special command for that. It's this WSL-D Ubuntu-bash-C. Yeah, that's a mouthful, but basically this means that the following part of the command is run under bash in WSL. We're going to use daemonize. If you don't already have that installed in your environment, I had to do an apt install daemonize in order to get that to work on my WSL environment beforehand. But that's really useful as it allows us to run this in the background properly. Then we'll use that daemonize program to run Ollama. I'm going to do it this way. We have to find some log files so we can track if anything goes wrong in the future. And we run the Ollama binary here with the argument serve. Then we change directory to where our .n file is so we can conveniently read that in for this batch file too. So you'll need to change this location. Then we'll get our signal telephone number that we're sending from, and we'll start the signal-cli daemon in the background with this command here. Once we've got those two things set off and loading up in the background, we wait another 60 seconds. Before I added this, my Python file would often go wrong because they weren't ready to talk to each other. And if there were any messages queued up waiting for the signal-cli to get them, it didn't have Ollama to pass them on to and something went wrong. So we wait a little while to make sure both are up and running first, and then we simply run the signal Mistral Python file. You can verify that works by running the batch file directly from your command line and then verifying everything works as you anticipate, but we want this file running at startup, so in Windows we need to use Task Scheduler. So if you open the Start menu and start typing Task Scheduler, you'll see it'll come up right at the top. You can see it's full of scripts. I've added this one at the bottom. You can add it using the Create Task button here. I named mine appropriately. I gave it the trigger of @logon of any user, and I set the action to start a program giving the path of the batch file. But not only that, I also filled in this start in. It seems to be important to be the same folder the batch file lives in. I left all these conditions as defaults, and I didn't play with these settings either. What are a couple of useful options are these two here. When you're debugging, you want to choose run only when user is logged on. You'll then see the command window come up and you can see the batch file running in the background, and you can make sure that it works every time you boot up the computer. But once you're sure everything is running properly, you don't want to see that every time you log on, so choose this option, run whether user is logged in or not, but we don't need the password. Then you won't see it at startup, but it will be running in the background. For some reason, configure 4 for me was set by default to something else, and I had to make sure it was selected to Windows 10. That's the platform I'm using. Now I don't have a particularly advanced computer. I'm running this AMD Ryzen 5 5600. I have a fairly old GeForce GTX 1060 6GB, so this is not a particularly powerful machine that I'm running this on. This is the Signal desktop here. I'm going to send a message to my bot. I'm going to ask it to do something fairly involved, and we'll see what the performance hit is. Write me a short and funny limerick. That's been read. And the typing ellipsis has come up, so it is now working. Let's go over to WSL and we'll run htop. It doesn't show properly in the Windows Task Manager, but you can see here, okay, it's using a fair amount of my memory here. Quite a lot of the threads are running. I can definitely hear my fans whirring. So yeah, it does use quite a fair bit of processing power. But now you can see all of that usage has dropped. It didn't take very long, and clearly it's done. Let's go back to Signal. A squirrel and a kangaroo were bestest friends, filling their days with fun jumps and amends. They played all day till the sun went down and shared tales of how they'd turned brown. One fateful day they had a fall, splitting their pants and making them small. Nice try, Mistral. But yeah, now that's not running anymore. It's really not taking up an awful lot of processing power at all. It's not a particularly noticeable impact on the system when it's not doing inference. And signal-cli uses Java, so best way to find what the performance impact of that is to find the Java process. And you see, that's not massively impactful either. It definitely uses some resources, but I haven't had much of an experience of a system-wide slowdown with this running in the background. Of course, when you actually do inference, then it takes some power away, but if you're the only person using it and you're away from your computer when you're sending messages to it, that should hardly be much of an issue at all. And in truth, I'd forgotten that I had this running at startup and in the background. I spent a lot of time playing VR games and there'd been no massive hit there. So I think when you're not actually using it, it's absolutely fine to have it ready and waiting for when you do need it. I certainly haven't found it too impactful. We got there. It certainly took me longer than I wanted to get this working, but you can get there a lot quicker than I did. I have published this as a Git repository on GitHub. So go on over to Dan Making with AI and you can download it. You'll need to implement your own .env file from the example, but at least you won't have to write all the code we've run through from scratch. So check out the provided GitHub repo for the project's code so you can easily start your own journey with this kind of a project. Let me know what you think in the comments. What use cases do you think you're going to use this for? With an autonomous agent accessible by Signal, what would you ask it to do? Let me know your thoughts and maybe suggest what you'd like to see me implement next. And of course, this is a small and very new channel, so if you like what you've watched, please hit the like button and consider subscribing if you want to see more like this, especially if you want to see me evolve this project into a remotely accessible autonomous agent. There's not much else on this channel yet, but if you're interested to see what AI tools I used when I first put this channel together, consider our previous video. Music, logo, channel description, it was all based on AI output, even if I've tweaked things a bit since then. Thank you so much for watching. I'm Dan Woodward. See you again soon.